So yesterday we were working with this same basic problem where we had the position of the particle represented by this same equation. And now we're just picking up from where we left off. The next question that we're going to answer about it is, what is the acceleration at time t? Now this is something that we saw earlier in the year, so we're bringing it back, reminding ourselves about it. Acceleration is the second derivative of position, or the derivative of velocity. And of course, remember we found the velocity equation yesterday. When we do that, you should get an answer of 6t minus 16. So that's our acceleration function. Now that we know the acceleration function, please use it. Please find the acceleration after 3 seconds.
That's pretty easy.
All right, now this is a pretty easy calculation, I hope. You're basically taking the 3 and plugging in for 2. So you end up getting an answer of 2 as your number. But notice the units on acceleration. Position is measured in feet. The derivative is with respect to time. So the first derivative is feet per second. But then the derivative of that is again with respect to time. So the derivative is then that feet per second that we had for velocity per second.
So every second.
And so think about what this really means then. After 3 seconds, our acceleration is 2. That means that our velocity is increasing by 2 feet per second every second along the way. So the velocity is increasing by 2 every second, is another way to say it there, and think about it. Now then, yesterday, remember we dealt with like what's the actual distance covered, stuff like that. We can use the same kind of stuff related to acceleration as well. So in order to be able to go further with this, I want to be able to figure out when is the acceleration positive and when is this acceleration negative.
Oh, I know what to do.
Now, remember yesterday, we talked a little bit about when's the velocity positive and negative. And you may recall that in order to do that, we figured out when the velocity was 0. And then we were able to figure out, okay, is it positive or negative on each side of those zeros? Well, in this case, we could start the same way. First, figure out where is this acceleration equal to 0. So please find that value right now. And so we're actually setting acceleration equal to 0 here. So we do 0 equals 6t minus 16. We solve that, so add 16 to both sides, divide both sides by 6. We get an answer of 8/3. Yes, if you wrote it as 2.6 repeating, that would be fine, but I like 8/3. It's got a little bit more style to it. I don't know. Next up, I want to be able to write out the intervals when the acceleration is positive and negative. Now, those intervals are going to be separated by the zeros. So we know that the dividing line between positive and negative is at 8/3. So then there must be 2 intervals. We're going to describe everything to the left of 8/3, and we're going to write an interval for everything to the right of 8/3. And so when you do that, this is what you should be looking at. Our first interval, that is the interval to the left, is negative infinity to 8/3. Notice, it does not include the 8/3. It is a parenthesis, not a bracket there, because 8/3, it's not going to be positive or negative. At 8/3, it's 0. So we don't want to include that there. All right, now that we know the 2 intervals that are candidates here, and we have to figure out which one's positive and which one's negative, we're going to do that. Now you got 2 options. Just like we did yesterday, we had 2 options about how to figure out if it was positive or negative for velocity. Option 1, we can graph this equation. We can graph acceleration, and then we can look at the graph to be able to tell when is it positive, when is it negative. The other option is that we can test points. And so we're actually going to go through and take a look at how each of those would look. It's a personal preference thing about which one you use. So let's start by taking a look at what the graph would be. So if I set up a quick set of axes here and look at what would the graph of 6t minus 16 be? Well, the minus 16 means we start down 16. Slope of 6 means we're going up 6 over 1 from there, so it's positive slope from there. So this would be our graph. Now, I just did a very quick sketch. Yet, you should be able to tell me in that sketch, what's that t value right there?
2.6667.
Yep, that's the 8/3, because that's where it's 0. So, to the left, notice it's below my t-axis, it is a negative acceleration because here we're graphing a versus t. And so that means that it is negative over that first interval from negative infinity up to 8/3. And that you can see it's above the axis to the right of it, therefore it's positive there. Now that's one way you could do it. And it's nice and easy in this case because it is just a line. However, you could also have done it by testing points, which also is not too hard in this case. Let's actually test a couple here. What's a nice easy number in this interval? 1's a nice easy one. 0 is also a nice easy one. Personally, if I can use 0, I tend to, so I'm going to go ahead and use 0 here. But you could use anything that's less than 8/3. And so a of 0 would equal negative 16. Since it's negative, that's how we would conclude that interval is negative. Similarly, if you were doing this just by testing, if you didn't make the graph, would you still have to test the other side too?
Yeah.
Couldn't we just assume that it was going to be positive?
No.
No. Because remember, these graphs behave differently. Now, if you were thinking, well, no, we don't need to test it. We already know what it's going to be because it's a line. Well, there you're bringing in the graphing idea. So I'm talking only by testing points. So if I tested another point, I'd test like a of something bigger than 8/3. So like 3. And a of 3, actually we tested that one earlier. We found that was 2. Notice it is positive, hence why that interval is positive. So we can know where it's a negative acceleration and where it's a positive acceleration based on that. Make note on your paper of where it is positive and negative for this problem, as we're going to need that information here in a little bit. Yesterday I gave you a bunch of notes, including about position and velocity. This is following up on that. Information about acceleration now. All right, and then a few little details coming out of this. You'll notice here I describe acceleration as the instantaneous rate at which velocity is changing at time t. Or, to put it another way, a equals the derivative of v. Because that's what instantaneous rate of change, of course, is. It's the derivative. Now, positive acceleration, 0 acceleration, negative acceleration. Make sure you see what each of those mean. Like 0 acceleration. Notice that does not mean that the object is standing still. It doesn't mean the object is at the same location where it started. It just means that the velocity isn't changing. So it's still potentially at least moving someplace, but we know that rate at which it is moving isn't changing if the acceleration is 0. And this stuff ends up having some very interesting applications. So here I've given you a graph of a position function. And it's going from 0 to 10. Looking at that graph, think for a moment on your own first before we talk it through. When is this object speeding up? And when is this object slowing down? So we're looking to see when it's speeding up, for instance. Well, of course, speeding up means when is its velocity getting bigger? Well, this is a position function. Velocity is the derivative, so like this tangent line right here would represent the derivative. That is the speed, the velocity at that particular point. If I compare that velocity to this velocity here, did our velocity get bigger or smaller between those 2 points? Bigger. So we know that here, at least between these 2 points, it was speeding up. When does it stop speeding up?
Oh, I read it. It stopped speeding up right there because it just.
Well, let's see what is it over here. I'll see if I can sketch a better one. So like right here. If I compare this to this, did our velocity get to be more or less?
Less.
Less. So somewhere in there it started slowing down, right? And so it's a little bit different to look at. Specifically, these are actually our intervals. It is speeding up from the very start up until right around here.
Okay. Wait.
And then it starts slowing down because our slope starts decreasing, which means that my velocity is decreasing. A decreasing velocity means that the acceleration is going down as well then. Now, if you were just thinking about what's the acceleration, that's where things get tricky with this. Because the acceleration here ends up going positive and negative both here. And so think about, for instance, what is the velocity? Let's go actually look at that first one, that first interval, speeding up. So in this section here, is the velocity positive or negative? Well, remember, to know if the velocity is positive or negative, we're looking to see, is the slope of our position graph positive or negative? That's a positive slope. So velocity is positive there, right? What about in this next interval where it's slowing down? Is the velocity positive or negative? Well, my slope is still positive, so the velocity actually is still positive there. Okay, next let's go to this speeding up section. Over this section, is my velocity positive or negative? Negative. It's negative, because my slopes now are going down. And in the last interval, when it's slowing down here, what's my velocity? Is it positive or negative? Negative. My velocity here is negative. So notice, there doesn't seem to be any direct connection between whether we're speeding up or slowing down and that velocity sign. Okay, now let's look at the acceleration. In this section, this first section, my velocity is getting bigger. And so because my velocity is getting bigger, my acceleration is positive. Okay, the next section over. In this section, my acceleration, it's how my velocity is changing. So my velocity goes, for instance, from there to there. Did my velocity number get bigger or smaller? Smaller.
Wait, how?
Because I have a steep slope like of 1 here to a slope of, say, a half. So we got to be less there. So my acceleration was negative. Because acceleration negative means velocity decreasing. Okay, next up. In this section, is my acceleration positive or negative? Well, think about, here's a slope at the start. Here's a slope there. The slope here is, let's say, 0, right at the very start. My slope here is, let's say, negative 1. Did it get bigger or smaller?
Bigger.
It didn't get bigger.
Smaller.
It went from 0 to negative 1.
Leon,
That means
stop down.
it got smaller. This is a negative acceleration here. Now, you might be thinking, but it got steeper.
Yeah.
It did get steeper, but it got more negative. We're just looking to see, did the velocity number get bigger or smaller? The velocity got to be smaller.
I get it. It's like it still increased, but increased in a different
Yep, it increased in the negative direction.
Increase and slow down.
Okay, what about in this last section?
This is positive.
Positive.
Let's say we have negative 1 and then negative like a half. It got bigger, yeah. And so that's a positive acceleration. And so, now seeing that, there is a connection that we can now see. Can you tell from that information what makes it speeding up and what makes it slowing down? And so, one thing we can see is that it is speeding up when velocity and acceleration are both positive. But when else is it speeding up? They're both negative, yeah.
Oh, because a double negative is a positive.
And so, if both signs are the same, it's speeding up. As opposed to, if the signs are different, notice it's slowing down. The reason is because a positive acceleration, remember, means my velocity is getting more. Well, in order for it to be speeding up, I have to have a positive velocity that's getting more positive. Or a negative velocity that's getting more negative. And hence, that's why the signs have to be the same. If the signs are different, what it's saying is, like, for instance, the velocity is positive, yes, but it's getting less positive. And therefore, it would be slowing down. It would be getting closer to 0. And speeding up means getting further from 0 for my velocity, and slowing down means the velocity is getting closer to 0. We can basically summarize it in this table here. This would be a good thing to add into your notes. Now going back to our problem that we were working with earlier, we want to know when is this particle speeding up and when is it slowing down. Well, thankfully, we've actually already done all the legwork, all the hard work in order to be able to answer that question. Because we want to know when is the velocity positive and negative, and we want to know when the acceleration is positive and negative. So we already have all of this information from before. Now it's a matter of how do we use it. I'm looking for the combinations. I'm looking for when is velocity and acceleration the same. So a great way to do this, it's not the only way, but a great way that you can do this is actually do it visually. So notice I drew a little number line there, and on that number line I put in a break at every single one of these different numbers that we saw here, because those are all the various breaks that I can have in my intervals. And now I just want to go through and I want to start describing what is what here. So let's go over this interval first, from negative infinity to 1/3. Is my velocity positive or negative?
Positive.
Yep, velocity is positive. Is acceleration positive or negative?
Negative.
Slowing down.
Negative. Okay. Between 1/3 and 8/3 now. Is the velocity positive or negative?
Negative.
Yep, we're now above 1/3, so we're into this one. So yes, the velocity is negative. And the acceleration, positive or negative? Well, we're still below 8/3, so it's this one right here. So you can see acceleration is negative. And so then we fill in all the rest of them. And for each one, I'm just looking to see, okay, the numbers in this interval, which one is it matching to over here to know if it's positive or negative. So it's all based off of those intervals that we wrote earlier. Now, of course, remember, this work, we actually did quite a bit of work to get those. This one's just pretty easy because we had already done all that work there. But now that I can see this, I do have one last step. I still have to say where it is speeding up and where it is slowing down. Now, looking at our picture, it's not too hard to be able to tell, I hope. Because remember, for it to be speeding up, the signs have to be the same. So I have speeding up here and here. So speeding up, and then it is slowing down wherever the signs are different. So now we need to write those out. How would I write where it is speeding up?
From 1/3 to 8/3 and
Yep.
5 to infinity.
And what do we have to put between those intervals? Yep, exactly. We have to include the union. And so then this would be our final answer for this problem. 1/3 to 8/3 and 5 to infinity to speed up. So the last thing is to put this process about how we tell when it's speeding up and slowing down into your notes, because it is a process and we need to be able to keep track of what our steps were in order to get there. So add this into your notes, please.